Hello guys, welcome to my channel. So today I'm going to talk about the last video of this series that I was working on from few months. So in the last video we talked about microservices, and as planned we are going to work on REST API in this video. So before we actually do that, if you haven't seen all the previous videos, take a look at my YouTube channel. You will see all sort of videos there. And if you haven't yet subscribed to my channel yet, please do. It's a simple thing and it will keep me motivated to make more videos like this. So if you are done subscribing, then let's kickstart this video. Alright, so the very first question: how do you handle partial updates in REST API? Explain patch request and how do they differ from put. So patch is basically a partial update, and the purpose is to partially update a resource, and it will only send the fields that you want to update. So for example, let's say that you have a user resource with these properties, so ID as 1, name as Alice, and other details, and if you only want to update the email, then you would want to send a patch like this. So here you are sending a patch request users ID1, and then you are only sending the email. So that is the only field that is going to get updated in the database. Now talking about put, it is actually a full update. So the purpose is to replace the entire resource. So if you send the complete new version of the resource, then it is going to overwrite the existing data. So here in this example you can see that we have used put for users and ID1. So here I'm providing the entire data as name, email, role, and that is going to overwrite the existing data. So if we omit any values or fields in a put request, then those fields might get reset or removed. So keep that in mind. Now let's see the difference here. So here, just to summarize, type of update in patch is partial and in put it's full. Payload wise, patch only do changed fields, but put does entire resource. Risk of loss. So for patch it is lower because here we are going to work on few fields or a single field, so others won't get affected. But in put it is going to be quite higher because we are going to work on the entire resource, so there are chances that missing field may be lost. Now use case, patch is to update a few fields. So if you want to update few fields of the existing data, then use patch. If you want to replace the entire object, then use put. Alright, now summarizing, use patch only when you have to update a few fields and if you want to minimize the risk of accidental overwriting of data. Use put only if you are confident that you will have the full new state of the resource and if you want to completely replace it. Now moving on to the next question: what is Hetios in REST APIs and how is it implemented in Spring Boot? So first let's talk about Hetios. So Hetios stands for Hypermedia as the engine of application state, which is a key concept in RESTful API design. So this allows a REST API to provide hyperlinks with responses which clients can later on use to discover related actions and resources dynamically. So think of it like instead of clients hard coding the URL for related actions like updating or deleting a resource, here the API response includes those links. So here if you see in this example, we don't have any links here. We don't have any hyperlinks. It is just having ID, title and author because this is an example without Hetios. But talking about the example where you will have Hetios, here you can see that you will have ID, title, author details. Along with that you will also provide links, right? So here you have hyperlinks for book ID and books. So here you will have a self, update, delete all books. So these kind of operation you are doing on those URLs. Now how to implement Hetios in Spring Boot? First thing is that you need to add the dependency. If you're using Maven, then you have to add the dependency like this. So here we have Spring Boot starter Hetios. Once you do that, you have to create a resource model using entity model. So entity model is a key concept again from your Hatios framework. So a simple entity model wraps a domain object and add links to it. So that's the functionality. So this is a class, and here what we are doing is we are translating basically all the links to entity model. So you have get book by ID, which is again a mapping, or you can say a method. Then you have get all books, update book, delete book. So these are some of your methods which basically you are converting to a link, and it is inside entity model. So entity model in Hatios wraps a resource like an entity and adds hypermedia links like self or update, and it is used in REST APIs to make responses more discoverable and navigable by clients. And that is what we have done here. Then you simply have to use that in your controller. So in my controller method, you can see that I have used toModel method, which is basically doing that stuff for me. Now, what are some benefits of Hatios? So we have already discussed this. So clients do not need to hardcode URLs. That's the major benefit. Then it makes your RESTful APIs more discoverable and self-explainable, right? So if you print all the APIs for your client, so he sees all that stuff upfront, so he can use it. So it makes it more reachable. Now this encourages loose coupling between client and server. Why? Because you are not hard coding URLs, right? How do you design APIs to be backward compatible during versioning? So let's first talk about backward compatible. So what does it mean? So it means existing clients continue to work with the new version of your API without any changes on their end. So here we need to follow some best practices to ensure backward compatibility. So first is we need to use URI versioning. So every time whenever you create any kind of API or method, you need to provide a version. So you can initialize, if you are creating it from scratch, you can initialize it with version 1. So here in this example, you can see that I have get mapping and the URL is API v1 users, right? Now when a breaking change is needed, we need to expose a new version. In that case, you just need to update it from v1 to v2. So it is much more readable, as well as anyone can understand that this is something new. So a benefit here is that this is very easy to implement and there is a clear separation. But disadvantage is that it can lead to duplicate logic across versions. Now second is avoid breaking changes. So we need to try to evolve our APIs without removing or modifying existing behavior. For example, you can add new fields which basically your client will ignore if they don't need that. You can add new endpoints, but you need to avoid changing field names, data types, or semantic. Also, you don't need to remove existing field or endpoint. So this will try to keep the user experience intact like before. Alright. Now third is we need to use optional field instead of required ones. So we need to design payloads so that new clients can send new fields without breaking old clients. So you need to take care of regression. So here in this example, you can see that the old payload was having only name and email, but in the newer one, you can also add phone. So this is not breaking the old functionality, but providing you a new feature. Now in Spring Boot URL versioning, commonly we use something like this. Here you can see that in the request mapping we have version 1, and this is to get all users, right? So this is version 1, so this is old. Now here you see that you have another mapping API version 2 users, which is basically another new controller, and here you also have get all users, which is version 2. So this will return improved version with new fields or structure, right? So you have two methods now, one with version 1, another one with version 2, and here you can keep both of them running depending on whatever client require. So if it is an old client and if they are not using the new feature, then they can work with version 1, and if it is a new client requiring new features, then they can work with version 2. Alright, now let's move on to the next question. How do you handle large file uploads and downloads efficiently in REST API? So there are some best practices. There is no conventional way to answer this question. So talking about uploads first, so what are some best practices? So first would be to use streaming instead of buffering entire file. So we need to avoid loading the full file into memory, because if you do that and if it is a very big file, in that case your memory consumption is going to be quite large, which will make your application inefficient. So here we need to use multipart file dot get input stream for streaming, and in this example you can see that in the try block I have used that, and then you can either try to stream it to disk or to database, or maybe to any cloud framework. So you have multiple options there, but here you are not actually loading the entire file into memory, rather you are streaming it. So this will give you slight edge over the conventional way. Now second is to increase max file size in Spring Boot. So in application.properties you need to use these two properties, which basically is for multipart. So if you are using multipart, then you should use these two properties. So here you have max file size and max request size. So keep both of them to 500 MB. Now third is, like I said, save to disk or cloud instead of DB. So here you can also save it to DB, that's okay, but if you have a lot of large files, in that case you should store these files in a dedicated file system. So you can try to have S3 bucket from Amazon, or you can either use a local disk or Azure Blob, right? Then you should be only saving metadata like file name, path, size in your database, so that you don't need to do heavy queries just to fetch or insert data to databases. Now fourth is to handle uploads asynchronously. So for very large files, we should be offloading processing to a background thread or queue. Because if you work on synchronously, in that case, when the first file processing is done, only then your second file processing will start, right? But here we should not be actually prioritizing one file over another. If there is no need, then you should work on it asynchronously, and here you can use Spring async annotation or RabbitMQ etc. to handle this scenario. Now second portion, how to handle large file downloads. So again, best practices we are going to talk here. So first is again to use stream, and here you can use it with response entity. So streams file directly to client without full buffering in memory. So in this example you can see that I'm creating a file, but I'm actually streaming that file later on, and then I'm returning that stream of file as a response, right? Now second is to use range request for resumable downloads. So there are some downloads which you can pause and later on resume, right? So in that case, Spring Boot supports this via http servlet response.set header, and here you need to accept ranges to bytes. So for full resumable support, we need to customize this logic to serve byte ranges. But again, you can use range request for resumable downloads. Now third is, which is optional, to use compression. So if the files are text based like CSV, JSON, XML, in that case we can use gzip compression. So this basically helps you out in a longer run, but it is actually not a convenient option. Some follows it like from the heart, and some don't, because when you compress it, then you need to uncompress it as well whenever you have to read it, which again cause some intervention, right? So these are some best practices which you can use to handle large file uploads or downloads. Now moving on to the next question, how do you implement custom error handling in Spring Boot? Explain the use of controller advice and exception handler annotation. So the second statement is the answer to your first question. So you need to use controller advice and exception handler annotations to implement custom error handling. So let's first talk about exception handler. So exception handler annotation allows you to handle specific exceptions inside a controller. So here in this example, you can see that we have a mapping, get mapping of an ID. So let's suppose if this ID doesn't exist, as in the user couldn't be found. In that case, I would like to throw an error, and that exception should be printed beautifully to my client. So how do I do that? I will have another exception handler method in this very same controller class, and here I will have the type as user not found exception. So here what I'm doing is, instead of throwing the entire stack trace, I'm just throwing the status, which is HTTP status not found 404, and in the body I'm mentioning the message only, right? So this is going to be much efficient, and here I can prioritize working on what custom exception I'm throwing. Now second is global exception handling. Again, talking about the difference, so you should first think of exception handler like this is going to work for very specific exception. So if you have, let's say, some custom exception created and not going to enlarge that functionality, then use exception handler. But usually we don't have that scenario. Usually we have a general or generic scenario where you need to do generic kind of exception handling. So for that very same purpose, you have global exception handling. So here you can use controller advice annotation if you want to globally handle exception across multiple controllers, right? So in this example, you can see that we have exception handler methods. So here we have three methods of three types. First is your user not found exception, second is method argument not valid exception, and third is exception. For every scenario, I'm handling it like whatever I would like to. So for example, if I want to print 500, then I can do that for any exception. So it's up to me, and in this logic you can see that I have differentiated it based on what exception I'm getting. But the general exception is the third one, which is your exception. Here you can see that I'm throwing internal server error because I don't know what happened. So that is why I'm printing an unaccepted error occurred. Alright, so if let's say I don't get user not found exception or method argument not valid exception, then it will come to exception method. Now third is you can create custom error response model as well. So instead of returning raw messages, we can create a structured error response. So here I have a Pojo class where I have status message and timestamp. So I can use this to print a beautified message in to my client, right? So here in this example, you can see that the output would be like status 404 message user with ID 5 not found and the timestamp. Now, one thing that I would always recommend is that you should be using correct status code. So if you see that something is not found, you should be using 404 and not 500. Right? So if something is not found, that is 404. If it is a bad request, which will basically comes under when validation fails, in that case use 400. But if something goes wrong unexpectedly, in that case only you should be using 500. Now moving on to the next question, what is the difference between bean validation and method validation? So valid annotation is standard Java bean validation, which comes from Java X validation valid and Jakarta validation valid. So depending on which version of Spring Boot you are using, you will have either one of these packages. Now this is used for validating fields inside. So this is used for validating fields inside a class or method parameters, especially your data transfer objects. And this is often used in controller methods. So in this example, you can see that in my post mapping, I am creating a user, but I also want to validate if the data that I'm getting, which I have to basically insert, is it valid or not. So if validation fails, Spring will return 400 bad requests automatically. I don't have to do anything here. But if nothing goes wrong in the validation, it will return user created. Now user DTO here has annotations like not blank and email. So here Spring will take the responsibility of validating not blank, as in the name should not be blank, and email has to be in a proper format. Now second is your validated annotation. So this is Spring specific for method level and group validation. So this comes from Spring framework itself, and it supports everything valid does, plus it does your method level validation, not just request bodies, and it also does your groups validation. So in this example, you can see that we have used validated annotation on your entire user service class. So this will work only if validated is present at the class level, and for this to work, Spring AOP must be enabled and the class must be a Spring Bean, like a service or a component or a controller. Now what is the difference here? You can see in the summary that valid comes from JavaX or Jakarta X.validation package, but validated comes from your Spring framework.validation package. Here the scope of valid is bean, field and method params only, but validated scope is bean, field, method params plus method level validation. Now valid does not support group validation, but validated does. Also valid does not support method level validation, which we already talked about, and validated does. Now framework standard, which is your Java EE for valid, but Spring for validated. Now moving on to the next question, how do you secure REST API using Spring Security? Explain the use of JWT. So let's first talk about why do we need JWT, because JWT is how you secure REST APIs. So JWT is required because it is stateless, scalable and secure. Why it is stateless? Because it has no server-side sessions. So the token itself carries all necessary information. Why is it scalable? Because it is ideal for microservices and distributed systems. Why is it secure? Because signed tokens prevent tampering. Now how the authentication flow works in your JWT. So user logs in with the username and password. Your server then authenticates and generate a JWT token. And this JWT token is stored at your client end, for example your local storage, and then it sends it with each request like your authorization. So here you will have a bearer token. So server then validates the JWT on every request, whatever you will do later on, right? Now key components in Spring Security and JWT setup. So how do you implement this? First is that you need to add these dependencies. So first is your Spring Boot starter security, then JWT API, then JWT IMPL and JWT Jackson, right? Then you will need a JWT utility class, which basically handles all the things that you will do with JWT. So first is you will generate a token. Second is you will extract username using that token. Third is you will validate token, right? So generate token works on a username. Extract username will work on token and your secret key. Then validate token again will use your token and user details. Then you will need an authentication filter. So this basically means that whatever you will do when you are logged in, so when you authenticate, you will have a proper flow. So here the JWT auth filter class is used to intercept every HTTP request once per request only. So here we are extracting and validating the JWT token, which comes from your authorization header, which is basically your bearer token. Then it will authenticate the user by setting the authentication in the security context if the token is valid. In short, it ensures every request is checked for a valid JWT token before hitting secured endpoints. Then you will have a Spring Security configuration file, which you have to use whenever you use Spring Security. So Spring Security is going to work on your Spring Security filter chain and auth provider. So filter chain basically defines how incoming HTTP requests are secured. So here you configure what routes are public or private, like you have to either permit all or you can restrict it, right? Then you can also add filters like your JWT auth filter. Then you have authentication provider, which basically tells Spring how to authenticate a user. So usually that is done from your database. So it uses user detail service and password encoder to verify credentials. Then in the login controller, you can provide these logic to generate the token, authenticate, and return with the response. Now moving on to the next question, how would you prevent CSRF and CORS vulnerabilities in REST API? So CSRF means cross-site request forgery. So it seems like a big word, but it's simple. So CSRF basically is an attack that tricks a user's browser into making unauthorized requests on their behalf. For example, transferring money while the user is logged in. Now, why REST APIs are mostly immune? So REST APIs are usually stateless and use JWT or API keys and not cookies. So CSRF exploit browser cookies. If your API does not rely on cookies for authentication, CSRF risk is minimal. Now, when to disable CSRF in Spring Boot? So if you're using token-based authentication like JWT, you have to disable CSRF protection. So here you can use like this. You have http.csrf and then csrf to csrf.disable. Now second, what is CORS? So this is cross origin resource sharing. So this basically again is a browser security feature that blocks cross origin requests unless the server explicitly allows them. So for example, your front end is at localhost 3000 port and your backend is at localhost 8080. So here the browser will block calls unless CORS is configured. Alright, so if you work from scratch on a project, let's say your backend is Spring Boot, which basically uses 8080, and if you're using Angular, which uses 4000, then the very first request is going to be blocked if you don't handle CORS. Alright, now how to do global CORS configuration. So here you can see that in the configuration I'm adding the mappings that should be allowed. So here all the mappings are allowed. Then I'm allowing origins, which basically means the URL that you want to allow. So here I'm allowing my front end. And then what methods do you want to allow? If you want to do it for every method, then you can also do that, but here I have specified for few. Then headers I'm using as anything. Then credentials to true, which means that I want to allow credentials, right? Now CORS via security config. So this is preferred if you are using Spring Boot 6 plus versions. So here you can see that I have again security filter chain and CORS configuration resource. So security filter chain is similar to what we have talked before this question, but cross configuration source cross configuration source is used in Spring Security to define CORS rules for your API. So here what we have done is we have allowed few things whatever we want to allow. So if your front end tries to call your backend, the browser blocks the request. So here I have allowed localhost 3000. Now what this will do, this will tell Spring which domains can access your API, what HTTP methods are allowed, which headers are allowed, and whether credentials like cookies or authentication header can be sent. So the first option was your global CORS configuration, which will work for anything. The second is your CORS via security config. So this is with your Spring Security. Now moving on to the next question, how do you implement an API gateway using Spring Cloud Gateway? Explain key features like routing, filters, and rate limiting. So what is Spring Cloud Gateway? So this is an official API gateway by Spring, and this is built on top of your Spring Webflux, which is basically your reactive programming framework, then your project reactor, again reactive programming, and then it is very much ideal for non-blocking asynchronous request routing. So implementing an API gateway using Spring Cloud Gateway is straightforward and powerful. So this acts as a single entry point for all your microservices, handling tasks like routing, security monitoring, rate limiting, etc. So how to implement API gateway? So I think I have talked about this in one of the video, but let's talk about it anyway. So first thing is that you need to add dependency in your pom.xml. So for example, here you can see that I have used Spring Cloud Starter Gateway. Then you need to use Spring Cloud POM, so which is your Spring Cloud dependencies, which I have done here again in POM. Then in your YAML or properties file, you have to add the route configuration, and here you can see that for the ID user service, I'm routing to URI 8081. For order service, I'm routing to 8082, and also I have predicates as path, which is basically starting with users, and for order service it is starting with orders. Now key features. So key features are your routing, filters, rate limiting. So what is routing? Routing directs incoming request to appropriate microservice. So this is based on predicates like path, method, header, etc. So in this example we have used path. Now filter. Filter basically is to allow to modify request or response or add behaviors like logging, authentication checks, etc. So in this example, we have added request header filter. So you can see that in this example. Now we can also create custom filters by implementing gateway filter. Now rate limiting. So rate limiting is used to prevent abuse and protect services. So for this you need to add Redis dependency for distributed rate limiting, and first is that you need to add this dependency in your POM. So Spring Boot starter data Redis reactivate. Now in your YAML or properties, you need to add this in your filters and arguments. So here I have used rate limiter replenish rate to 10 and burst capacity to 20. So replenish rate means that 10 tokens, as in 10 requests, are added to the bucket every second, and think of it like saying allow 10 new requests per second. Now burst capacity, so this sets the maximum number of tokens the bucket can hold at once. So it allows for burst traffic. For example, if no request was made for 2 seconds, the bucket might have 20 tokens. Now just to summarize, routing is to route request to appropriate microservices. Filter is to modify request or responses. Rate limiting is to protect services from abuse. And we are done with this question. Also, we are done with the video. So if you have loved the content that I have shown in this video, please press the like button and subscribe if you have not done that. And I will meet you in some another video. Till then, stay happy, keep learning. Bye bye.